just in case Valerie doesn't join us, then I've made a video for her. So Stella was thankful for unicorns. Eleanor, what are you thankful for?
My father.
Oh man, that might be the best one. That might be the best one ever. I was so thankful for my father. Oh my gosh. And how about you, Jason? What are you thankful for?
My mom.
Oh, that's beautiful. That's beautiful. Well, we've got unicorns, we've got fathers, we've got moms, and guess what I'm thankful for?
What?
I am so thankful for such great students. And I don't just call you my students, I call you mathematicians. And my favorite people in the world, don't tell anybody, are mathematicians. Okay? So those are my favorite people. And so I'm really thankful for that. And I wanted to share that with you. So every time we do fun math problems, do you always find yourself looking at something called operations? And the operations are multiplication, division, addition, and subtraction. And these are called the 4 binary operations. Now, every time I see a math problem, I'm always thinking about, what do I do? So if I wanted to, for instance, find out how many unicorns I had, and I started out with 3 unicorns, and then Stella gave me another 2, and then Jason borrowed 1 from me and took 1 away, but Eleanor said, hey, I'm going to give you 4 of my unicorns. We actually are dealing with addition, subtraction, and then addition again. Who can tell me how many unicorns we're dealing with here? On 3, say it. 1, 2, 3, go.
8.
There are 8 unicorns. That's exactly right. Now, what happened if every time Eleanor's father saw a unicorn, he gave Eleanor a nickel? Now, let's say that we know that a nickel is worth how many cents?
5.
5 cents. So let's say that Eleanor's father saw 15 unicorns, and we wanted to know how much he would have to give Eleanor in cents. So we know 15, and we would use multiplication. We would use times, because for every one of those unicorns, Eleanor is going to get a nickel. And does anybody know 15 times 5? It's kind of a fun math fact. On 3, try it. 1, 2, 3, go. All right, let me try it like this. 5 times 15 is the same as 5 times 10 plus 5 times 5, and 5 times 10 is
50.
And 5 times 5 is
25.
And if we smush them together, we get 15 times 5. On 3, 1, 2, 3.
75.
Exactly. Now, what if I had 20 unicorns? All right, now this is a true story. Mr. Kramer has 20 unicorns.
Wait, what?
Yep, only 20.
No way.
Now, believe it or not, every time I have a unicorn, I know that he takes up about 1 square foot per foot. So his foot, which kind of looks like that, that's the foot of a unicorn.
Wait, what?
It takes up exactly 1 square foot. So I've got to figure out how many square feet I need for 20 unicorns. So I'm going to have to say, all right, we're going to do what? How many feet does a unicorn have?
4.
So are we going to use multiplication or division?
Multiplication.
That's right. So 20 unicorns times 4 legs tells me how many feet I need. On 3, 1, 2, 3.
80.
How many?
80.
80. That's right. Now, what if Jason's mom has 100 candy bars and she wants to give an equal amount to Eleanor, Jason, Stella, and Valerie?
And Mr.
And,
Kramer?
well, let's first just do Valerie. So how many pieces of candy would each of Eleanor, Jason, Stella, and Valerie get? What would we use? Multiplication, division, addition, or subtraction?
Division. Division.
So 100 divided by what?
4.
And what is 100 divided into 4 equal pieces on 3? 1, 2, 3.
25. 25.
That's right. You guys each get 25 pieces of candy. Now, let me ask you this question. I want you to answer this honestly. Are you ready? What if Mr. Kramer said, you know, I'd really like to share in Jason's mom's candy? Now you would have to divide 100 by what? Come on, how many are we now? Eleanor, Jason, Stella, Valerie, and Mr. Kramer?
5.
We are 5. So now, how many pieces do each of us get? On 3, 1, 2, 3, go. Think about it this way, guys. If I have 100 and I divide it by 5, 5 goes into 10 how many times?
2.
Look up. 2. 5 goes into 0.
0.
Guys, you know that you now get only 20 pieces of candy. So Eleanor, you're going to have to give up 5 pieces of candy, 25 minus 20, if Mr. Kramer is allowed to share in the candy. Are you willing to do that? Jason and Stella, are you willing to do that?
Maybe.
Maybe. Now here's the problem. My wife said she would like to be part of this as well. So did, yep, and so did Eleanor's dad, and so did Jason's mom, and so did Valerie's mom, and so did Stella's mom. So now we have 10 people that are going to share in the candy. Now, I don't know if you're okay with this, but we're going to have to divide 100 by what?
10. I mean 10.
Yeah, now there are 10. And what is 100 divided by 10? Go.
10.
Yep. Now, you guys just went from 25 pieces of candy each down to 10. Are you okay with that?
Yeah.
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 And I don't think we want to share with anyone else because 10 pieces of candy is the minimum number of pieces of candy that anybody needs. Okay, do you guys agree with that?
Yes. That's
It's got to be 10 pieces of candy. Okay, are you guys ready? Now, here's the problem now. We've got Anna is bagging hair clips that she made. She's going to put 4 clips in each bag. She has 28 hair clips to bag. How many bags will she need? And I want you to write this down. Pick up your pencils, write the multiplication problem or the division problem or the addition or the subtraction, and then you can answer it. So Stella, write it down first.
I'm just asking you a question.
Of
Can I go-
course, sweetheart.
Can I go to the bathroom?
Oh, you don't have to ask. You when you need to go, you always go. And Jason, I assume, Eleanor, you're working on this? And now if you have any questions, let me know what they are. Okay, Eleanor, I'm going to let you answer this one first, but don't give me the answer before you give me the equation that you created. And then I'm going to ask Jason to give his as well. Go for it. And Jason, listen to this, buddy, and unmute yourself, okay?
28 cut into 4.
So 28, and what's the operation?
28
Multiplication.
divided into 4.
Oh, so we say 28 divided by 4. We say 28 divided by 4. And Jason, can you tell me what that is? That beautiful equation that Eleanor came up with? Jason, go for it. 28 divided by 4. And you'll have to unmute yourself, buddy. Come on, hit the button. There you go. 28 divided by 4 is what, Jason?
It's 60.
Say one more time.
60.
60. So 28 divided by 4 is 60 or 16?
16.
Can you take your hand away from your mouth? Because I think that that's making it difficult for me to understand you. Would you do that for me? Thank you.
7.
Oh, that's very different. So 28 divided by 4. And Eleanor, is that what you came up with?
Yes.
So she will need 7 bags. And Stella, do you know any way that we could check their answer? We had 28 hair clips to bag, and she has to put 4 hair clips in each bag. And do you know, how could we check their answer?
7 times 4.
Oh, everybody check it out. 7 times 4. That's the opposite of division, multiplication, equals 28. That was awesome. That was awesome. Now, I want to do this next one. But before I do it, I'm going to draw a circle. And then I'm going to draw something called, let's see if I can do this. This is called a dodecahedron. Does anybody know how many sides has a dodecahedron? Go ahead, Eleanor.
How?
Yes, a dodecahedron has 12 sides. And do means 2, and deca means 10. When we add 10 to 2, we get exactly 12.
What
So
is the
watch-
circle for?
Well, the circle represents something that we use every single day. So let's see if I can get this to happen. Ooh, I did it. I did it. Now, what we're going to do is we're going to clone that page. And let's actually, if I draw a 12 here, then what should I put on the very bottom? Any ideas?
X.
And what should I put northeast? Right over here. Think about it. At a 9, well, if this is 12 and that is 6, then this must be 5, 4,
3.
3. And then what about northwest of 6? So west of 3 would be what?
9.
9. 9 is exactly right. And now we can fill in all the missing pieces. And what does this resemble to you?
What does resemble mean?
What does it look like? What is it similar to? Go ahead, Eleanor.
A clock.
Right. This is a clock. So a clock goes back to the old ancient base 12. So the base 12 number system was very, very important. And we have a few things left over from the base 12 number system. We have clocks. And what's the other thing we have from base 12? Something that where one special thing is 12 equal parts. Can you think of anything else that deals with 12? How about foot? So doesn't 1 foot have 12 inches? Isn't that cool? Is there anything else that is 12 in our number system? And by the way, I just want to say that this is the end of November. Come on, guys. In 1 year, we have, there you go. We have 12 months. So there's so many wonderful things left over from base 12. And I don't know how old it is, but I think it's about 1,000 years old that civilizations used to use base 12. We are luckily on a base 10 number system, and that's a good thing because we have 10 digits on our fingers and 10 on our toes. So it makes it easier for us to count. Now, if this is a clock, what does each of these red marks represent? Go ahead, Stella.
Like on some clocks, there's these little lines that represent like 5, 10, 15, 20, 25.
20 what? So what do these red marks represent, Stella? You're right. Eleanor, what do you think?
Minutes.
Yeah. So if you're talking about 1 hour, then 1 hour has how many minutes?
60.
60. So if there are 5 minutes from here to here, how do we get 60? 5 times what?
5 times what? 16.
12.
That's right. So 5 times 12 equals 60 because there are 12 hours in the one rotation of the clock. And therefore, we have 12 times 5 is 60 minutes. That's 5 times 10 plus 5 times 2. Fantastic. All right. Now, let's actually do a little bit of time. So I'm going to make this a little bit bigger, and maybe I should make it into a different color. How about orange? And I'm going to make this, let's see, the style of this. And okay, that's good. So I'm going to put, wait a minute, where is it? There we go. I'm going to put this right here, and that's going to be the minute hand. And then I'm going to do the same thing, but maybe I'll use green. And this is going to be the hour hand. Who can tell me what time that is? And we're not right now talking about AM or PM. It's just the time on the clock. Go ahead, Stella.
1 o'clock.
1 o'clock. Interesting. Now, if the hour hand was pointing to the 1, and if the minute hand was pointing to the 12, that would be 1 o'clock. Does that make sense, Stella? Okay. Who can tell me what time it is now? Do you want to give it a try, Jason? Go ahead, buddy.
12 5.
Ah, it's 12 for the hour. And how many minutes? 5.
5.
1, 2, 3, 4, 5. So that's 12 o'clock, 12:01, 12:02, 12:03, and 12:04, and 12:05. Pretty cool. Now, what about that guy right there? And I guess what I'll do is I'll mark off the little markings for the minutes. Eleanor, can you do this one?
12 o'clock.
Well, it's definitely after 12, but look at it, Eleanor. Whoops, that was weird. But we went, Eleanor, from 12 o'clock to 12:05, 5 minutes more, and then a few minutes more. So what would that be, do you think, Eleanor? Think about every one of these is 5 minutes. Just give it a try. It's okay to be wrong. Remember, that's 5 minutes. That's 5 minutes. And that looks like 2 minutes. So how many minutes after 12? If you want some help, just say, I'd like some help. What do you think, honey?
I don't know.
Okay, Stella, give us an idea.
12:12.
Yeah, and can you explain it to us, please?
Well, I mean, I got the idea when you circled like 5 minutes and then 5 minutes, and it looks like 2 minutes. So I decided to add them together like 5, 10, and 12.
So you're saying that this is 5 minutes, this is 5 minutes, and this is 2 minutes. Eleanor, do you see that? And since 5 plus 5 plus 2 is 12, we can call that 12:12. 12:12. Now, I have a very special time to give you guys. Are you ready? This is one of my favorite times. And I'm going to mark the minutes. And you tell me if you know what time it is now. And by the way, just so you know, and this is not something you need to worry about, after 12 o'clock, the hour hand also starts to move, but it still means it's after 12 o'clock and not yet 1 o'clock. And it's just moved around a little more than halfway to 1 o'clock. So who thinks they know that time? And Jason, why don't you unmute yourself so when I call on you, you can answer right away. Okay, Jason, what do you think?
12, 34.
Ah, does anybody see why Mr. Kramer loves 1234, Stella?
Wow.
Look at these digits, guys. One, come on. What is it?
Oh, because it's like 1, 2, 3, 4.
It is 1, 2, 3, 4. Jason, beautiful, beautiful job. So
I was
guys,
thinking that same answer.
say again.
I was thinking that same answer.
Oh, that is awesome. That is awesome. Now, what I want to do now is I'm going to go to a special set of problems. Let's see if it worked. No, that did not work. It's not what I wanted. But let's see if I can get these special math problems with clocks. I think I found them. So let's see what we have. So we're going to start with this first one. And we're supposed to write the time on the clock. Now, I'm going to make a hour hand. And then I'm also going to make, I'm also going to make a minute hand. Now, what's kind of fun about this is that if you look at the hour hand, it's not yet at 11 o'clock. So it's gone from 12 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9, past 10 o'clock, but not yet to 11. So what do you think the hour would be? Remember, past 10 o'clock, but not yet to 11. What would go right here for the hour? On 3. 1, 2, 3. That's right, because it's past 10, but not yet at 11. Now, when we look at the minute hand has gone from 0, 5, 10, 15, 20, all the way around to 10 fives and 1 more. So who thinks they know? Don't say it out loud. Don't say it out loud. Who thinks they know how many minutes has passed 10 o'clock? Remember, there were 10 groups of 5 plus 1 more. 10 groups of 5 plus 1 more. On 3, 1, 2, 3.
51.
That is right. If we count, guys, everybody, let's do it. Let's count by 5s. Ready, go. 5.
10, 10, 15, 20, 25, 30, 35, 40, 45, 50. 50.
and 51. You
I wonder
guys,
why they made those little dots.
which dots, honey?
Like besides that line,
That dot, like those dots right there?
those little dots.
Yeah, well,
Okay.
those dots represent every 5 minutes. Now, I'm going to do the same thing now, but this is the hour hand. And then if you like the color of my minute hand, why don't you guys now write down the exact time, the hour and the minutes. And I'd actually like you to work out the rest of these problems. And I'm going to go to the bathroom really fast. I'll be right back. And you guys do as good as you can, but just try to work on it on your own. I'll be right back.
All right. How did you beautiful?
Who wants to do the first one? Okay, let's go with Eleanor and then Stella and then Jason. Go for it.
Use 34.
Whoa. And that's just 2 hours after that special time that Mr. Kramer really likes, which is 12:34. That's just 2 hours later. Okay, Stella. I'm not sure I understand, Jason. Stella, go ahead, buddy.
4:57.
Ooh, 4:57. I really, really like your 57, Stella. But is it 4:57? Think about how much time has passed. And in 3 minutes, it is going to be what time? Because remember, the hour hand moves during the hour. So is it 4:57? Eleanor, what do you think?
3:57.
Ah, so Eleanor, could you explain that to us, please, so we understand it really well? Go ahead, Stella. I mean, Eleanor, sorry. Can you explain that, please?
And it's not 4 yet.
Yeah, it's not 4 o'clock yet. So do you see this hand right here, Stella?
Yes.
At 3 o'clock, it was pointing to the 3. And then as it gets closer and closer and closer to 4 o'clock, it's going to be pointing to the 4, but it's just slightly not pointing yet to the 4.
I can't tell because
It's really hard to tell. And then in 3 minutes, it's going to be 4 o'clock. So 3:57 is the actual, but Stella, that was great. And Eleanor, thank you so much. Now, Jason, tell me what's going on. This one's a little bit easier to read, I think.
38.
Ah, very nice. And Stella, do you see how it's after 5 o'clock, not yet 6 o'clock, and he's gone minute hand from 12 to 6, which is 30 minutes, 35, 36, 37, 38.
I definitely saw that.
Yeah. Now, I want to ask you guys to write down 4 more times. And I'll tell you what I'd like it to look like. It's going to be the time that is 10 minutes later than the times that we already calculated. So this would be 10:51 plus 10 minutes. This would be 2:34 plus 10 minutes, 3:57 plus 10 minutes, and 5:38 plus 10 minutes. Go write down what you think. Okay, so I want to ask you guys, Stella, could you start us off by telling us 10 minutes later than 10:51?
11:01.
Wow, that was awesome. Does everybody agree with that? 10 minutes later. Very, very good. And what about you, Eleanor? Do you want to do the next one? Eleanor, what would be 10 minutes later than 2:34? And if you want some help, just say, need a little help. And try to do this on your own. Think about the minute right now is 34. We want 10 more. So you want to add 10 minutes to 34 minutes. What would that give us?
2:44.
Exactly right. And what's 10 minutes after that, Eleanor?
2:54.
And then here's the big challenge, Eleanor. What's 10 minutes after that? This is the-
3:04.
What? You are awesome. 3:04. Now, Jason, what about you? Can you do 10 minutes after 3:57?
4, 4, 7.
Nice. Very, very nice. And Stella, could you tell me 10 minutes after 5:38?
I've got 5:48.
Very, very nice. I think you guys are going to be great at telling time. And it's not something that everybody knows how to do because everybody reads digital clocks now. And digital clocks really don't teach us much about base 12. And so I love base 12. Now, this one's a little bit more difficult because we don't have a clock in front of us. So hold on a second, guys. Sorry about that.
What is she doing?
So the TV show starts at 6:25 p.m. and it ends at 7:10 p.m. How long is that show? And so you guys want to really think about this. And you can answer the question in terms of the number of minutes. And you can also answer it in terms of hours. What do you think? So let's start with you, Jason. How many minutes do you think this is?
4, 3, 5.
Wow, that's really nice. And Eleanor, do you know how many hours that is? 45 minutes? Or did you have another question you wanted to ask? How about you, Stella?
I think
Are you guys thinking about the fraction?
10 minutes?
Say again, honey.
1 hour and 10 minutes.
Well, 1 hour, everybody look at this. 1 hour and 10 minutes, which we can write as 1:10, is how many minutes are in 1 hour, Stella?
60.
And 60 plus 10 is how many minutes?
70.
So therefore, 1 hour and 10 minutes is 70 minutes, not 45. My question was, what portion of an hour is 45 minutes? And let's look at Mr. Kramer's clock, okay? If I look at this clock, and I know, are you guys ready? And I know that this is 5 minutes. Now I want to go all the way to 45. Jason, look up here. So I go 5. Come on, guys, read with me.
10, 10, 20, 25, 30, 35, 40, 45.
Now stop right there. Stop right there. Now, If I look at 45 minutes, what fraction of 1 hour is 45 minutes? So we know that this is 45 minutes. But this is what fraction of 1 hour? Come on, guys. What fraction is this? If I have a circle and I have a certain amount of that circle colored in.
3/4.
Right. We call that, very nice, Jason. We call that 3/4. This is 3/4 of 1 hour, or 3/4 hours. It's 3/4 hours. So this is 3/4 of an hour. Now, going back to this page here, which is really kind of fun. Wait, hold on. Let's do that again. And okay, here we are. So if I know that if I have minutes and I have hours, so I know that 45 minutes equals 3/4 of an hour. Who can tell me how many hours is 30 minutes? Remember, 30 is 10 plus 10 plus 10. On 3, 1, 2, 3.
10. Half.
Everybody, it's 1/2 of 1 hour. It's 1/2 of 1 hour. That's exactly right. And what if I had 15 minutes? Now, 15 minutes is just 5, 10, 15. What portion of 1 hour is that? Remember, we know that 45 minutes is 3/4. 30 minutes is 2/4, or 1/2. What is 15 minutes? On 3, 1, 2, 3.
5. 1 over 6.
Well, does anybody else have an idea? Eleanor? What fraction would that be? And just think of it, Eleanor. Look at the blue. And there are 3 of those that make up 3/4. So what does 15 minutes make up, which is just one of those pieces? Go ahead and say it if you know it. Stella, do you know it?
5 over 6.
Not exactly 5 over 6. Because remember, it's 15 minutes. Let's try this a little bit different.
1 over 4.
Let's see if Jason is right. Guys, if we go 15 minutes, that means that we are covering what portion of 1 hour? Come on, Stella, you know that fraction. Eleanor, do you know that fraction?
1/4.
Of course. And that's what Jason said. This is 1/4. So 15 minutes is 1/4 of an hour. Now, let me ask you this. I'm going to go to this one here. And I'm now going to say that the number of minutes is going to be 10 minutes. And what I'm going to do is I'm going to color in 5 minutes and then another 5. And the question is, what fraction of 1 hour is 10 minutes? So these are 10 minutes. Wait, hold on, Jason, hold on, buddy, hold on. Learn to raise your hand. It's really important. So I want everybody to be thinking about this and think of how many you could create with this. How many of those pieces are there? And I'm just going to start coloring other pieces, which are the same size. And I want you guys testing. That's 3 of them right there. And there's a red one. That's another one. Raise your hand if you want to share your idea about what fraction is 10 minutes. And I'm going to do one more. Whoops. And let's see if I can do one more. There we go. All right, come on. Everybody on 3. You're telling me what 10 minutes is. On 3. 1, 2, 3, go.
1 over 15.
Did you say, oh, 1 over 16? Jason?
6.
So guys, how many of these pieces do you see? 1. Come on, 6.
Over 6.
3,
4,
4,
5.
5, and 6. So when Jason said 1/6, he is absolutely correct. 10 minutes makes up 1/6. And guys, what about 5 minutes? It would just be half of that. It would be this one right here. What does that make up? Now there are 12 of those pieces. There are 12 of these pieces. And what do you think they're called? On 3. 1, 2, 3, go.
112.
Exactly. It is 1/12. So 5 minutes is 1/12 of an hour. Now, the last thing I'm going to do is do something that's really, really crazy, guys. Look at this. If I wanted to fill in 1 minute, do you know what is equivalent to 1 minute? How many of these pieces would we need to fill up an entire hour?
160.
That is right. It is 1/60th. We would need 60 of those pieces to make up a whole. Can you believe it? So I want you guys to spend a lot of time looking at analog clocks. These are called analog clocks as opposed to digital. Like on my phone, I'm sorry, my watch right now, this is called a digital watch. But let me see if I can get analog. This is analog. So there's second hand. It's a little hard to read. Everyone is digital. This one is analog, but that's really hard to read. Ooh, this one is my favorite one. It's really easy to read. And do you see the seconds moving?
Yeah.
And it's going
What are the minutes? What are the hours?
10, 9, 8, whoops, 7, 6, 5, 4, 3, 2, 1, blast off. So now there is 1 minute left. Now, my favorite one is this one right here. And that's,
Minnie Mouse.
and I don't know if she talks. Let's hear her. No, she's not talking to us right now, but that's also an analog. And if you can see, her one hand is the hour hand and one hand is the minute hand. So I want you guys to see wherever you can find analog clocks, and the more you can tell time and talk about the fraction of the hour, the more you will learn about this. So I hope everybody has a lot of fun with this type of mathematics. And I will see you guys in exactly 167 times 60 minutes. So if you want to do a little bit of math, you have to multiply 167 hours times 60 minutes, and that will tell you how many minutes we have until
Times
we
1
see
hour?
each other again. That's right. There's 60 minutes to an hour, and we have 167
Hola.
hours till I see you next.
Class right. I have another class right now.
Yeah, go, go, go. Oh, she had to go. All right, guys. Great seeing you. I'll see you in a week. Bye, guys.
Bye.
See ya.
Bye-bye. Move your hand. Move your hand. Bye-bye.